Okay, so let's see how powerful are modern computers. Okay, so maybe you know, maybe you don't know. This is some concrete example numbers. Supercomputer. The IBM has the most powerful one, a supercomputer in the world. It can do 10 to the 24th flops, floating point or addition, multiplication, those kind of operations. 10 to the 24 per second. Okay, that's, okay, maybe I should go back. And this is that huge monster. And PC is still very fast. Right now, the PC, maybe 10 years ago, is a supercomputer. 3 gigahertz, basically, it can do roughly 10 to the 9th operations per second. Okay, they are very, very powerful. But if you really want to see how powerful computers are, then your question is, what can computer really do? Well, as a machine, without mathematics and instruction, clever instructions, the computer can only do this simple operation, but it can do fast. You know, you don't want to do this tedious, but they can do it and fast, but nothing else. So a simple example, you know, if you still remember your calculus, then how do you sin x? You cannot use, it's not addition minus subtraction, multiplication, addition, sin x, but we use it every day. Well, if you have some calculus knowledge, you know, you can turn it into a simple multiplication, subtraction, addition, division. So you reduce these things into such a simple operation. That's a little bit play of mathematics. Of course, as mathematician, we don't do this. Okay, what does math have to do with it? Okay, so let's see. What we usually do as a mathematician to deal with a real-world problem is first we have to do mathematical modeling. In other words, you have to transform a real-world problem into a mathematical problem with quantitative relation in a precise and concise way. Okay? So without that, you really don't know how to study it. You describe this phenomenon, that phenomenon, but if you want, you're the computer, you want to study it, understand it more, you need to translate it into a mathematical problem. In another word, we all know one picture is worth 1,000 words. To many study, one equation is worth 1,000 words. Okay, it's described many, many things. I'll give you examples. Then after you turn into a mathematical problem, then you can do many things. Also mathematicians are doing. One is mathematical study. The main thing is you want to use mathematical tools, calculus, more advanced tools, to maybe you can solve it, write out explicit formula. Maybe you cannot solve it, but at least you know the relative relation between, you know, this force and what's the acceleration. That's, you know, what I'll give you a simple example. Some relations between different quantities and so on and so forth. And many times you have a very good understanding of the problem. If that's not still enough, many times the problem is so complicated, you cannot write an explicit formula. You may know more quantitative information rather than qualitative. Then, with nowadays computers, you have some powerful tools to help you. Then, you have a complicated equation, you don't know how to write out the formula, but what you can do, you can design efficient algorithm and let computers, by doing some simple operations, but vast number and fast, and you can get more quantitative or numerical information of the problem. So that's usually how mathematicians, or in the real world, how we deal with the problem. We use all these things to address the issue in hand. So let's give you some very everyday life experience in what computers do with mathematics. Well, some of them are, you know, some of them you may not be aware of.